All right, good morning, good afternoon, good evening, wherever you are. I hope you're doing great. We are about to talk about triangle or inequalities within triangles. So what I'd like you to do before we get going here is I'd like you to actually go ahead and write down the section number and title at the top of your paper that you're going to be taking notes on. Again, that's 5.5, section 5-5B, if you want to be really specific. And then just go ahead and jot down, we're going to be talking about inequalities within triangles here. Now, as I continue to flash through this, so you've got inequalities within triangles. I'm going to see if I can advance us forward here. There we go. Okay, we're going to go past that. All right, so I want to go back. There we go. All right, so here's what I'd like you to do on your paper there. Now that you've got that section number and title down, I'd like you to go ahead and jot down this triangle right here and label all the vertices and information that we have up here. Now as you do that, just pay attention to what I'm saying as we move along. So yesterday what we talked about was how the side lengths influence the angles opposite. Okay, so the longer the side, the larger the angle opposite that side there. And then what we said, what I'm going to tell you for today is everything's the same but in reverse. So what we're going to be looking for is, okay, what's the order of the side lengths within this triangle? What's the order from least to greatest? Okay? And if you have enough understanding of what we talked about yesterday, today's lesson should be really simple. Okay? So as we take a look up there, I think the first thing that we should probably do is figure out what angle T is going to be. And so if we go ahead and take the 180 degrees that we have in the triangle and subtract the 58 that we have there and the 62, angle T is going to have to be 60 degrees here. So I'm going to put down 60 right there. Okay? So the question then becomes, which side's the shortest side? Well, I hope, based off what we talked about yesterday, that you can see that this angle has an influence on that side right there. And since it's the smallest angle within the triangle, that side TV is going to be your shortest side. Okay? Now, as I continue to move on, oh boy. Sorry, I don't know why that keeps popping up there. Interesting. As I move on, the next largest angle has an influence on the next longest side. So UV is going to be even larger than TU. And then as we look, the largest angle is opposite the longest side, so UT is going to be our longest side length. So again, I don't think that's a very hard concept. Hopefully you picked up on it as we look at this. So the next thing I want to do is I want to move forward and take a look at this next problem here, right there. Okay? I would like you to go ahead and draw that picture right there. I'd like you to pause your computer, draw that picture, label the vertices and label the angles, and go ahead and list them from least to greatest there. Okay, take a moment and do that. Excuse me. All right. Well, hopefully you paused your computer. Hopefully you went and figured out that this angle is going to be 80 degrees, because if I take 100 from 180, I've got 80 left over. Now, from there, I look up at my picture. I see that this is a 40-degree angle. So I know that YZ is going to be my shortest side length. Okay? If I go ahead and choose my next largest angle, which would be this one, that would mean that XY would have to be my next longest side length. Okay? And then my largest angle is opposite my longest side, so XZ. Okay? By show of hands there, folks, how many of you got that right? Put your hand down, silly. You know there's no one else around. Okay? All right. So from there, I hope that was understandable. If not, we're in big trouble. Otherwise, come see me. We'll talk about it. All right. Next thing I want to do is this. I'm going to bring up a quick video to help you understand the next concept. So what I'm going to do, let's go ahead and let's see here. I got to go back a little bit. I'm going to pause. All right, so I want to apologize about that. I thought I had the video pulled up already, but I didn't. So here's what I want to ask you. If you look at those three lengths, 4, 5, and 8, could I form a triangle? That's what we're going to be looking at over the next couple minutes. Is it possible to form a triangle based off the given segments that we have? So in order to understand this, I hope in your head you're making a guess, making a hypothesis here. I believe that it will form a triangle, or I believe it won't form a triangle, and here's why. Okay? So what I'm going to do to prove to you that either it can or cannot be formed a triangle, I made this length at 4, okay? I made my compass length that length. I brought it down here, placed the tip right here, and made a mark up here. Now this arc right here, all the points in that arc are 4 units from that endpoint right there, okay? Then I measured the length of this segment, which is 5 units, and I'm going to do the same thing over here. I'm bringing my compass down, I'm going to rotate it over, and I'm going to make an arc. All the points in this arc are 5 units from this endpoint over here. Now what we are finding out is that where those two arcs intersect, well, that point is not only 5 units from that endpoint, it's 4 units from that endpoint, and it does form a triangle. Okay? I'll speed this up a bit right here. Okay? So again, with those 3 segment lengths, we understand that the triangle is formed. Okay? Now, if I move on to the next figure, the question is still the same. Can I form a triangle with these 3 side lengths right there? Now, again, I hope in your head you're thinking either yes or no and trying to justify why. So, as I go ahead and make this arc, all these points on this arc are 4 units from that endpoint right there. Okay? If I go to the other endpoint, or the other segment, 7, I'm going to make this arc, all these points will be 7 units from that endpoint. So where does that intersection take place right there? Well, it looks like it might be a little bit above, because if it's up in here, then I can go ahead and form a real tiny triangle right there. The problem is this. The intersection doesn't take place until right there. It's kind of like a drawbridge. You have 2 sides of the drawbridge that come down, and it makes a flat surface right on top. Okay? So with these 3 lengths, it will not form a triangle. Now, the last type of problem that I want to look at with you guys has these side lengths. 4, 6, and 15. Okay? Now, will those 3 side lengths form a triangle? Well, I think that most people when they look at this, they're going to understand that, yeah, it's not going to form a triangle. But let me just prove it to you if you're a skeptic and you think that it might be able to form a triangle. So this compass rating is at 4, and all these points along that arc are going to be 4 units from that endpoint. I'm going to do the same thing from the other endpoint, but make it 6 units long. Not very good. Doesn't form a triangle. So kind of like the drawbridge example that I just told you guys. If you're going to jump or try to get across that bridge, you're going to have to make a good jump. So here's what I want you to do. Take a look at these 3 examples that we've been looking at. What is it about this first example that allows us to say, yes, this will form a triangle? What is it about these 2 examples that don't allow us to form the triangle? Think about that for a second. Now what I hope came to your mind as you looked at that is this theorem right here. In order to form a triangle, the sum of the 2 smaller sides must be greater than the largest side. Okay? And we can see that there. The sum of 4 and 5 is greater than 8, but the sum of 4 and 7 is not greater than 11, and 4 and 6 is not greater than 15. All right, so here's what I want to do. Let's go back to our examples here. Let me pull up that PowerPoint. Okay, and let's continue to work through some of these. Now there's a lot of examples here that I could show you guys, but I think you guys had that first concept down. Let's look at this one here. In this problem, and I'd like you to write this down. Actually, all you have to write down in your paper there is triangle question mark. Okay? And so what I'd like you to do is, after that, write down the 3 feet, 7 feet, and 8 feet. Okay? Now, for some of you that caught on to that concept that I just showed you are immediately saying, I know what the answer is going to be. The answer is going to be this. All right? But I still want you to write this down, 3 feet, 7 feet, and 8 feet. Now, how do I know the answer? The sum of the two smaller must be greater than the largest. Okay? And then, 3 plus 7, we know that is equal to 8. And so as a result, I know that this is going to form a triangle. So what I would do is put yes or true, and then I would write comma, this will form a triangle, just to make sure that you understand what's going on. Okay? All right, so let's look at a couple of other examples here to make sure we've got this down. Okay, what about that one? Is that going to form a triangle? I hope you're thinking no, because 3 plus 6 is not greater than 10. Okay, that's like our 4 and 6 and 15 segment triangle that we tried to build. Okay, what about that one right there? 2, 7, and 9. Well, again, I hope you're thinking no. This one's like the drawbridge example that we did. Okay, 2 plus 7 has to be greater than 9. What about 4, 6, and 9? Well, 4 and 6 are both greater than 9, so that does form a triangle. Okay, I shouldn't say they are both, but together they are greater than 9. Okay, what about the next one? 4, 7, and 8. Will that form a triangle? Now again, 4 plus 7 is greater than 8, so yes, it will. Okay, what about the 4, 4, and 4? I hope you're going to say yes, because 4 plus 4 is greater than 4, and as a result, we have an equilateral triangle. Okay? Now, there's one last type of problem that I would like to show you guys, and so I'm going to quickly click through all these ones right here. This one right here. I'd like you to jot this down. Oh, there we go. I'd like you to jot this example down in your paper there so that you have information to go off of. Okay, and again, I want to see the notes here if you've missed the class. So in this one it says this, and I want you to write this down. A triangle has sides of lengths 8 and 10. Determine all possible lengths. So basically I'm asking for what's the range of possible lengths for that third side. So determine the possible lengths of the third side of the triangle. Now what's key in this problem here is understanding one thing, and that's this. When we look at the previous theorem, the sum of the two smaller must be greater than the longest. The key was knowing which one was the longest, right? Well, as I look at the two side lengths I'm already given, the question then becomes, is 10 the longest or not? And the answer is we don't know. Okay? So as a result, I have to write two different inequalities here to figure out what that range for the third side length will be. So it's either going to be 8 plus 10. So in this case, I'm going to say that 10 is not the longest. It's one of the two smallest. Is greater than x. X is the longest side right now. But 10 could be the longest side, so I'm going to do 8 plus x is greater than 10. Okay? So from there, if I go ahead and solve for x, in both of these examples here, I should be able to figure out the range of the third possible length for the third side. So in this one, I've got 18 is greater than x. Okay? Now, a lot of people like to read from left to right. I just read from left to right. But it's actually more beneficial in this one to read from right to left because I got to start with, I want to know what x is. Okay? And you don't read from left to right and figure out what really x is. 18 is greater than x. Well, it kind of tells me, but let's start with the x. X is, now if I read backwards, less than 18. And so that tells me that 18 is my upper bound. Like if I get to 18 or greater, that's outside of the third possible side length possibility. In this one, if I go ahead and subtract 8 from both sides, I get x is greater than 2. All right? And most people can come up with the two inequalities, but I want to challenge you guys to put it into one inequality. And here's how I'd like it to go. first of all, notice my smallest numbers on the left, largest numbers on the right. That's how the number line goes, and that's how we should write down our inequality. So we've got that there. Now from there, if I read this, x must be greater than 2, reading it from right to left, and then reading it from left to right, and x must be less than 18. It's got to be both of these. That gives you your upper and lower bound so that we can know our range of possibilities for that third side length. So the question might be something that ensues, could the third side length be 5? Uh-huh. Yep. Could the third side length be 19? Nope. It's outside that range. Could the third side length be 17.5? Yep. Okay. So we want to make sure that we think through that process there of what are the third side length possibilities. All right, I'm going to give you one last problem here. Okay, this one right here. The two side lengths are 3 and 12. Take a moment, again, pause your computer, make sure you've got this down. It's too simple of a concept not to understand. Okay? So you've got 3 inches and 12 inches. Pause your computer, see if you can figure it out. Okay. Hopefully you're able to get that down. The two things that we need to know, again, 12 may be the longest side, it might not be. So if I do this, 3 plus 12 is greater than x. This tells me that 12 is not the longest side. Or 3 plus x is greater than 12. This tells me 12 is the longest side. And now I want to solve for x. So here we have this. Again, reading from right to left, x is less than 15. And then I have this. So the range of possibilities has to be greater than 9 and less than 15. Okay, just like that. If you flip the inequalities, make sure you flip them back around, but that's what I'd be looking for. All right, the homework should be online. I'd like you to look that over. If you have any questions, let me know. I hope that was understandable. Thanks for being attentive, and have a good night.